If you just got a quote for a home EV charger and the electrician immediately said you need a panel upgrade, stop. Because for a lot of homeowners, that one sentence adds $2,000 to $5,000 to the job before anyone has even done the math. And the uncomfortable truth is this: a panel upgrade is sometimes necessary. But it is also one of the easiest ways to turn a simple charger install into an expensive, high-margin project. So in this video, I'm going to show you what actually determines whether you need a panel upgrade. When the answer is genuinely yes, and when you need a bigger panel, it's really just lazy electrical salesmanship. This is Logic Forge. We don't do hype. We do math, money, and risk. And if you're trying to charge an EV at home without getting bullied into unnecessary electrical work, this is the video you need. A lot of homeowners think panel size alone tells the whole story. They hear 100 amp panel equals bad, 200 amp panel equals safe panel upgrade, equals unavoidable. That is not how this works, because the real question is not what number is written on the main breaker. The real question is, what is the actual load on the house, and how much usable headroom is left? That's a completely different question. And this is where a lot of charger install conversations go wrong. Some electricians are cautious, some are lazy. Some just don't want to spend time thinking through load diversity, charging amperage, or whether the homeowner even needs a 48 amp setup in the first place. So the easiest thing to say is, you need a panel upgrade. It's simple. It sounds responsible. And it makes the invoice much bigger. There are 3 big reasons panel upgrades get recommended so fast. Reason 1. It simplifies the installer's life if they upgrade the panel. They don't have to think as hard about load margin, current usage, or creative lower amp charging setups. Reason 2. Bigger jobs are more profitable. A charger install might be a few hundred to a couple $1,000s. A panel upgrade turns it into a much larger project. Reason 3. Homeowners are scared of electricity. If someone says, your house might not handle it safely, most people stop asking questions right there. And that's understandable. Electricity feels dangerous. So people often accept the highest cost, most cautious answer as if it's automatically the most correct one. It isn't. Here's what actually matters. 1. Your service size, yes. 100A versus 200A matters. But it is only the starting point. 2. Your existing home loads do you already have? Electric dryer, electric range, electric water heater, central AC, or heat pump additional subpanels, or heavy shop loads, because all of that matters. 3. The size of the charger you're trying to install. This is huge. A lot of people talk about EV charging as if there's only one option. There isn't. You do not have to jump straight to a 48 amp charger on a 60 amp breaker. A lot of households are perfectly fine with 16A to 4A, 32A, or 40A charging. And those lower AMP setups can still be dramatically better than standard level 1 charging. 4. Whether the house has real usable headroom. This is where a formal load calculation matters. Not guessing, not vibes, not you're probably fine. Not 100 amps is too small. Actual calculation. Because the difference between safe enough borderline and upgrade needed comes from the actual load picture, not the sticker on the panel door. Let me make this practical. Scenario 1. 100 a panel, average house. Moderate driving you drive, maybe 30 to 50 miles a day. You don't need maximum speed charging. Your home has some electric appliances, but not everything is electric. In this case, a lower amp level 2 setup, say 16A232A, may fit just fine. This is exactly why a lot of people are being oversold, because they hear EV charger and think they need the biggest setup available. You don't. Scenario 2. 100 a panel, all electric house. High charging demand now, let's say electric range, electric dryer, electric water heater central. AC may be bigger square footage, and you want a 48A charger now. The load picture is tighter. A panel upgrade becomes much more plausible here. Not guaranteed, but plausible. Scenario 3. 200A panel. But bad assumptions, even people with 200A panels can get bad advice. Because some installers assume if you have 200A, you can do whatever you want. If you have 100A, you need an upgrade. Neither is automatically true. The correct approach in both cases is still understand the load, understand the charger size, Understand whether lower amperage solves the actual need. Let's be fair. Sometimes you really do need one. Panel upgrades are justified when the home is already heavily electrified. Existing service is near practical limits the owner insists on high output. Charging the panel is old, crowded, or in poor condition. Local codes/service conditions make the install impractical otherwise. So this is not a panel upgrades or fake argument. This is panel upgrades should be justified by load reality, not installer convenience. That's the difference. Before you approve a panel upgrade, ask 1. Did you do a formal load calculation? The answer is no, you are paying for a conclusion that has not been earned. 2. What charger amperage are you assuming? Because a 480A setup is not the only path. 3. What lower MP options did you consider? They didn't discuss 1.6A, 2.4A, 3.2A, or 4.0A options. That's a problem. 4. Is load management an option? In some cases, energy management devices or lower output chargers can avoid a full panel upgrade. 5. What exactly makes the upgrade necessary? You want a real explanation, not vague, just to be safe language? Here's the bottom line. A panel upgrade is not automatically a scam. A panel upgrade is not automatically a scam. But it is one of the most common places where EV buyers get pushed into expensive work they do not actually understand. The correct answer is not always upgrade or never upgrade. The correct answer is know the load, know the charger size, know whether the proposed setup fits your actual driving needs, and most importantly, do not confuse the most expensive answer with the most intelligent one. If you want to help pressure testing this decision, that's exactly why I built the EV home charging blueprint. It includes a panel load screening calculator, an electrician vetting scorecard, a wire gauge, cheat sheet, and the exact questions that expose lazy or dangerous install logic. If that's live by the time you're watching this, it'll be linked below. And if not, subscribe, because this channel is becoming the place where homeowners learn how not to get financially and technically steamrolled by the energy industry. I'll see you in the next one.